Hello again. How are you? Let's see if this works now. Yay! Okay, so now we're good. Is that right? We got sound? Now there's sound. Okay, good to see you all again. As you can see, it's been a while since we've done these sessions, and it's a real pleasure to be able to do this in official collaboration with MathCounts. It's been far too long since we had these opportunities, and I can see that we have over 100 people who are here today who are going to think about some math. Now, with MathCounts, there's a particular reason I'm very proud to do this. It's because I actually see that MathCounts is what got me really interested in math when I was younger. Actually, when I was in elementary school, I didn't really know what math was. But after I found out that MathCounts had interesting questions, I got hooked. And so the opportunity to work together with MathCounts is something that I feel is it's an incredible, it makes me feel very special because it's something that got me interested in math. And thanks to MathCounts for organizing this official collaboration. Here's what we're going to do today. Well, apparently, there are some problems for me to do. And that's because there were problems designed for practice competition number 4 in MathCounts. I haven't looked at these problems before, and that's on purpose. That's because my goal with doing these kinds of live streams is to help everybody see how you'd try to solve a question if you saw it for the first time. Is everyone ready? Let's go and play with some of these. Now, these questions are not available easily online, but they'll all appear here as we're using them. And the reason for that, by the way, is because actually all of these problems are copyrighted. Just as a very clear statement that we need to make, these are problems that we're using with the permission of MathCounts because this is an official collaboration with MathCounts. In general, you're not supposed to just copy the problems around. I also just realized something. 1 second. It looks like my microphone is slightly in the camera frame. If you don't mind, I'm just going to go and tip this up very slightly so you don't have this little fuzzy piece. Oh, there's an easier way. There. Okay, let's do this. All right, let's do some problems. What's the first problem? I can't wait. Raquel has collected some money. What's this about? Raquel has collected $3.80 in nickels and dimes. She has exactly 48 nickels. How many dimes does she have? Well, one of my goals here is to try to find interesting ways to do questions. If I see something like this with nickels and dimes, you could set up equations. But something that I like to do is I like to say, well, it's asking how many dimes you have. So you could start by saying, let's just pretend they're all nickels. And if they're all nickels, how much money would I have? Oh, we get to do some fun math computations. If you had 48 nickels, well then, I see. It's actually not even that complicated. This question is just saying how many dimes does she have. So we can just figure out if you had 48 nickels, well, how much money is that? Well, a nickel is 5 cents, right? And what's the easiest way to think of this? The amount of money I need to do is times 0.05, times 5 cents, okay? And if I want to multiply something by 5, the easiest way to do that is to multiply it by 10. But then you have to divide by 2. So if I multiply by 10 and divide by 2, that's the same as 48 divided by 2 times 10. And that's equal to 240. That's because it's easy to divide 48 by 2. And now 240, that's $2.40. So now if I compare, I had 380. 380 minus 240, let's do everything in cents. That means that the dimes are 380 minus 240 cents. Right? And 380 minus 240, what have we got here? So 380 minus 240, that's 140. And so what kind of an answer are we getting here? We're getting 14 cents, right? So the answer here, I think, 14 dimes if that's 140 cents. So I get 14 dimes. Let's see, is this the right answer? Let's go and get the moment of truth. It is, so it's good. So that was the first question here. I actually just realized that in my tablet here, that's right. My tablet is still touch sensitive. If you hang on a second, I need to just adjust my tablet very slightly. Here we go. Okay. Next question. At a certain middle school, there are 16 7th graders and 24 8th graders enrolled in algebra this term. What percent of the students enrolled in algebra are 8th graders? Oh, it's a percentage problem. So in that case, I have, 16 of these 7th graders, 24 of the 8th graders. All right, so I need to do fractions, right? So how many of them are 8th graders? Let's just write the fraction. The 8th graders we have 24 of them. And I need to know how many people there are in total. So the total, I have 16 plus 24. I kind of like those numbers. Somehow, when you add those two numbers together, the 6 and the 4 add to the 10. So it ends in a 0. And so it's 30. No, be very careful of carrying. It's 40. Somehow with these things, I'm always like, a little bit in the back of my head is always trying to make sure I don't make a mistake for forgetting to carry. So now if I need to know what kind of percent this is, it's 24 over 40. I guess I need to simplify that. 24 over 40. The way I often simplify is I look for these common factors. I see an 8. Maybe I can take a factor of 8 out of each. That's 3 over 5. This is funny. I should have been lazy and just taken a factor of 4 out, because then it's more obviously a percent. But 3 out of 5, if I convert to a percent, is actually 60%. There are many ways to see that. One way is that from the 5 to 100, it's by multiplying by 20. And so I should multiply by 20 for the top number as well. And 3 times 20 is 60. So this is equal to 60 over 100, which is 60%. Okay, that was fun. I guess that kind of makes sense too. Whenever I read a question, I kind of want to know, is that a reasonable answer? And yeah, maybe the fraction of people in algebra being in 8th grade is 60% seems reasonable. The more of these questions you do, the more quickly you'll even recognize that 3/5 is 60%. That's a common mental math trick as well. Okay, next question. Oh yeah, what's the answer? It is 60. Okay. Oh, fun fact, if you're doing math counts, be careful of the units. I don't have the exact answer sheet here, but here's a tip if you're doing the math counts competition. On the math counts competition, if the answer blank has a percent sign next to it, you don't put the percent sign in your answer. You just write the 60. Because otherwise it's like 60%. And math counts, you have to be careful about units. That's why the answer to this question, apparently, was 60. Next question. What positive integer is 56 less than its square? Oh my, the questions got hard already. Actually, usually with math counts problems, the beginning ones kind of warm up, and then after a while they get more complicated. But this particular one, I like this because it's making me realize that's why algebra was invented. You see, because if the number is x, I mean, you could do this by guess and check, okay? You could do it by guess and check. But there's something else here that's quite nice. if the what positive integer, if that was x, you're trying to figure out how to make x squared minus x, the square minus itself, equal to 56. There are a couple of ways to solve this. This is a quadratic equation. You could use all of the methods you know to solve quadratic equations. But there's a way I was solving it in my head, which was, I can factor x squared minus x. This is not how you're actually supposed to solve quadratic equations. But on a problem that is this nice, because the answers are integers, I can get away with this. So x squared minus x is x times x minus 1. Do I know any two numbers where they differ by 1 and they multiply to 56? Actually, you do. That's because we memorize our multiplication table, right? And we know 56, that's 7 times 8. 7 and 8. So this one's 7 and this one's 8. So the answer is x equals 8. Fun fact, does anyone know why this asked what positive integer is 56 less than its square? It's because if you just ask what numbers are 56 less than their squares, there are two answers. It's because you could be negative, I see. I think that's Angie who has already posted that as a comment in the YouTube live. Because if you had negative 7 and negative 8, that also multiplies to 56. So that's why the question asks about positive integers. Oh, before I get so confident, I should make sure the answer is 8. It's 8. Okay, next question. Each year, a certain tree doubled in height. This is a crazy tree. Doubling in height every year is an incredible skill. Okay, at the end of 6 years, the height of the tree was 32 feet. What was the height of the tree at the end of 3 years? Okay. So this is one of these questions where at first it might seem like, oh, I need to figure out what it started with. But you don't. Because you see, at the end of 6 years, its height was 32 feet. Okay? And I care about it at the end of 3 years. So let's not even bother about how it started. Instead, let's just go and say 6 down to 3, that's 3 doublings. So if I have 3 doublings to get me to 32, what did I start? What was it before the 3 doublings? 3 doublings in height equals times 8, right? Times 2 times 2 times 2. So if you times 8 and you get to 32, the height of the tree has to be 32 divided by 8, which is 4. I hope that's right. I'm always afraid of reading the question wrong, so let's check it now. So my proposed answer is 4, but I always am afraid of being off by 1. Sometimes with these things, it's like, is it the end of the year or the beginning of the year? But in this question, it says it's the end of 6 years and the end of 3 years. The number of 1-year periods when you go between ends of years is that you subtract the 6 minus the 3. And if you want to double check, it's like, how many years are there between the end of the 6th year and the end of the 7th year? 1. 7 minus 6 is 1. That's how I always check. So I think the answer is 4. It looks like a lot of people in the chat also think the answer is 4. And the answer key also thinks the answer is 4. Let's keep going. If a certain recipe requires 5 tablespoons of flour for every 2 ounces of butter, how many tablespoons of flour are needed if 2 pounds of butter are used? There are 16 ounces of butter in 1 pound. Oh, thanks for reminding me this. This is actually quite convenient that it reminds us how many ounces of butter are in 1 pound. Well, let's see. So I have 2 ounces of butter, 5 tablespoons of flour. I often, just to make sure I don't make a mistake, I like to label things. So if I have flour, and these are tablespoons. Table doesn't mean like tables of flour. It means like tablespoons of flour. Tablespoons of flour, and you have butter, which is in ounces. Okay. Then if I have 2 ounces of butter, it's 5 tablespoons of flour. And in that case, if I need to go to 2 pounds of butter, watch what I'm doing. I'm trying to avoid doing computation until the end. 2 pounds of butter is how many ounces? Well, the problem told us, thanks MathCounts, that there are 16 ounces of butter in a pound. So it's 2 times 16 here. You see why I did that? There's no point for me to actually multiply 2 times 16 and then divide by 2. because what I'm interested in is what happens here. It goes by times 16. So this should also go by times 16. So in that case, what I need to do here is I need to figure out, how many tablespoons of flour. It's 5 times 16 is the answer. So in that case, how do you multiply 5 times 16? We just did a times 5. The times 5 is divide by 2 and times 10, right? So the way you do this is, oops, not 5 times. It's 16 divided by 2 times 10. That's how I like to multiply by 5. I divide by 2 first, and then times the 10. That's easy, because 16 divided by 2 is 8, so it's 80. So I get 80 tablespoons of flour. Let's find out. It is. Okay, more questions. Ooh, a table. The number of rounds of golf. Oh, that's why they're golf balls. Oh no, those are golfers. Never mind. But the number of rounds of golf played by each golfer of an amateur golf association is shown in the chart. What is the average number of rounds played by each golfer? Express your answer to the nearest whole number. I see. Oh, this is a neat question. So I need to go and figure out the sum of all of the number of rounds played by anyone divided by how many golfers there are. Let me see if the next slide has more space and also the same picture. It doesn't. So in that case, I'm going to go back to this and I'll do it all right here. So I need to first know, average, right? What does average mean? It means add up everything and divide by the total. What does add up everything mean? Well, it means that I need to add up a lot of ones, some twos, some threes, some fours, and some fives. So if I actually wanted to do this average, my total number of rounds played would be 1 plus 1 plus 1 plus 1 plus 1. Those are the 5 rounds. I'm just doing this slowly to show how you do this problem. Right? Those. And then plus 2, because there are 2 rounds. There are 2 people with 2 rounds. Okay? And then plus 3, because there are 2 of these players which had 3 rounds, and so on. And you see I'm getting kind of lazy. I'm like, oh, do I really have to write out 5 5s? That's why we invented the multiplication sign. So I'm going to say, it's like plus ... We'll figure it out later. Divided by, well, how many are there in total? How many golfers are there? Well, there are 5 here. 2, 2, 3, and 5. The total number of golfers. 5, 2, 2, 3, and 5. Okay? I'm guessing the answer is just 3. Okay, we're going to do this anyway. But it says express your answer to the nearest whole number. And I'm like, this is so symmetrical. If I look at this, you sort of look at this picture. Another thing that averaging is that it's also sort of like if this was some big seesaw or something, and each of these was a person. So there's 5 people sitting on top of each other. Don't really know how you do that. But 5 people sitting on top of each other there, 5 sitting on top of each other there. And they're all sitting here and you want to know where the seesaw is going to balance. And I'm like, it's just got one extra thing over here on the 4. So it's going to balance somewhere between the 3 and the 4. Closer to the 3. I bet the answer is 3. But we'll do it the slow way anyway. Okay. But what we're doing here is just how would you actually figure out the average? Well, it's the total number of rounds of golf played by everybody divided by the numbers of players of each type. Okay? And we have multiplication. Let's not do 1 plus 1 plus 1 plus 1 plus 1. Let's just say 1 times 5. All right? So let's go and do this thing again. Let's actually work this out. So the average is going to be 1 times 5. I'm trying to think of where to draw this. I'll do it here. So it's 1 times 5 plus 2 times 2 plus 3 times 2 plus 4 times 3, because there's 4, 4, and 4. That's why it's 4 times 3 plus 5 times 5, all divided by the total number of players, which is 5 plus 2 plus 2 plus 3 plus 5. Okay? All right, let's go and do some calculation now. So what is this? How do I add these together? Let's just do it in our head. So it's 5 plus 4, which is 9, 9 plus 6 is 15, I think. 15 plus 12 is, what's 15 plus 12? 27? 27 plus 25 is 52, I think. Help me if my arithmetic is wrong, because if you've watched any of my live streams, you know I make arithmetic mistakes all the time. So I have 52 divided by, and on the bottom, let's add the 5 and the 5 and the, oh my gosh, 2 plus 2 plus 3, what is that? Okay, so 5 plus 5 is 10, and then that's another 7, so it's over 17. All right, so I need to know what is 52 divided by 17, rounded to the nearest whole number. I know what 17 times 3 is. 17 times 3, anyone know what 17 times 3? Let's just do it in the scratch work. 17 times 3, that's 21, 51. 51's a number that's stuck in my head for like 17 times 3. So what is this rounded to the nearest whole number? This is 3 and 1/17. Exactly as I said, it's like it's just barely past the 3. So my answer to this is 3. And actually the right way to do this question fast would have just been what I said here about balancing them. Because now let's stare at this thing, okay? Let's stare at this problem. It's actually quite a clever problem. If not for that person here, you know, this person who did these 4 rounds of golf, what if we just kicked them out? Okay, bye-bye, you're gone. So now this guy's gone. So since this guy's gone, look at how symmetric this is. Yeah, so this is so symmetric once you remove this person that it's like the average should be 3. Because it's equally spaced around the 3. There's like 2 people on the 3, 2 on the 2, 2 on the 4, and then like 5 on each end. And what effect could this person have? Very little, right? So, okay, they're back, but, you know, you didn't do much. I still wanted to work this out slowly, though, because it's an interesting concept. It's a useful concept to know how to calculate the average of lots of numbers if you just see a chart, which is why I wanted to do it out slowly. Okay. Yes. Yeah. Well said. Somebody was calculating what is the effect that it has. Yes, it has 1/17 of an effect. That's a good way to put it. Okay. By the way, somebody was asking how our timing is here. We are spreading this over 3 days, 1 hour each day. This will go until 6 o'clock. I'll try to do as many of these as I can. And we'll see if this takes us 2 days or 3 days to go through all the problems. Oh, we have to check if the answer is 3. It is. Next question. A book company charges a shipping fee of $3 for the first item in a package, $2 for the second item, and $1 for each additional item in the package. For example, the shipping fee charged for one package of 4 items is 3 plus 2 plus 1 plus 1, which is 7. How many dollars are saved by shipping 10 items in 2 packages of 5 items each, rather than 5 packages of 2 items each? We can do this. So we got like plan A and plan B, right? So one of them is where you have 2 packages of 5 items each. 5 items, 2 packages. I should probably have put the 2 in front of the 5, but anyway. 5 items and 2 packages. If I've got 5 items, well, look, we already know how to do it for 4 items. That's $7. So if I wanted to do... Oh, this is interesting. 2 ways to do the problem. 2 ways to do the problem. Let's just do it one way, which is like this straight up thing, and another one, which is kind of nifty. So 5 items, I know 4 items is 7. So what's 5 items? Just another $1, right? 1 more dollar. So 5 items is going to be $8 times 2, which is, let's put a dollar sign here, which is $16. That's plan A. And plan B is where we say, how about 2 items each and 5 packages? 2 items each and 5 packages, okay? And now, what's the 2 item cost? Let's read it carefully. $3 for the first, $2 for the second is $5, $5. So it's $5 times 5. And that's equal to $25. And so what's the difference? Difference is $9. Now it turns out there's another way to see this. The other way to see that the answer is $9 is because if you think about it, let's pretend that the way this company works is they say, yeah, you know, all this nonsense up there, there's another way to think of all of this. The way to think of this is that each item is $1. But the box, somehow when you make a package, the beginning of it is more expensive. And that's why I was checking. It's like all the packages are 2 items each, okay? So we're going to pretend that in this company, all the boxes are at least 2 items. So I'll say, but each box for 2 or more costs plus how much? Well, how much extra are you paying for the first 2? That's like an extra $2 for the first one, plus an extra $1 for the second one, and 2 plus 1 is 3. Does that make sense? The way you think of it is like, suppose I've got all of these like boxes that I'm sending with good stuff in them. I guess they're books. Books are good stuff. So we got all these books, and the way it works is, since both of these styles have like 5 items, 2 items, I get past this threshold of the first 2 items. So no matter what, on each of these packaging styles, I'm paying $1 for each item, but I'm paying an extra $3 for each box. So if I compare these two from like 2 boxes, this was 2 boxes going to 5 boxes, I have 3 extra boxes. And each box costs me $3. So 3 times 3 is 9. I wanted to talk through both of these for another reason. It's useful to know 2 ways of doing the same problem, because if you can check your answer by just doing it again a second way, and you get the same answer, it's got to be right. And also sometimes these problems, like if this problem changed it with like much bigger numbers, it would be less convenient to go and actually calculate out these costs. But it's far more convenient to just count the difference in boxes. My guess is 9. Wow, people have got some pretty crazy answers here, like 1 over the square root of 1 over 81. Well, you're right. It is 1 over the square root of 1 over 81, which is 9. Oh, stem and leaf plot. Algebra exam scores for 27 students are given in the stem and leaf plot shown. What is the arithmetic mean of the median and mode of the given scores? Yikes. Okay, first of all, how do you read these things? This is a very convenient drawing. This means that one of the people got 51 points. One of the people got 52 points. The stem and leaf means that this 2 means it's 52, because there's a 5 here. And check it out. We got all these people with scores of 68, 6, and 8. Let's go and figure out these different numbers first. First, we need to know, what is the median? How do you find the median of a set of numbers? The way to get the median is you want to know what's the middle number. And fortunately, this stem and leaf plot is very symmetrical. So the way I'll get the middle number is I would just knock out the same number of numbers from each side as we go in. And it's so symmetrical. So all of these cancel each other because I'm trying to go into the middle. And in the stem and leaf plot, the middle is going to be somewhere here. Is it actually legitimately this 5? I need to double check because I need to count carefully. I'm guessing that the median is this thing with the 5. I circle it just so I can stare more carefully. I see 5 things here, and I see 5 things there. So the middle is indeed 75. So I'll say that the median is 75. And now what is the mode? To get the mode, I've got to go and stare at this and look, is there any number that appears a lot? Oh, look at all these 1s. That looks like a mode. See all these 1s? There's like 4 71s. Wow, this is a hard test, by the way. Pretty hard test. 71. Yeah, so the mode looks like 71. Mode just means the most common number. And what does an arithmetic mean? Arithmetic mean just means the average, the normal average. And so all we have to do is to figure out what is the average of 75 and 71. What's the number that's halfway in between these two? 73. I see somebody said, it's just a mean. So what's in the middle here? I'll draw some arrow. I can just see it's 73 because that's halfway in between. Actually, there are lots of means. There's also a geometric mean and a harmonic mean. All of these are topics that we could go on and on about. They're really interesting. But just because today we're focused on trying to get through all of these questions, I'll just stop it at that. But just say, like, there's a lot of different kinds of means out there. And it's a really nifty question because I think Math Counts wanted to have all of us think about mean, median, and mode, which are these three measurements of central tendency. I think that's what it's called. But it's just ways to find out what's common or what's in the average. So I think the answer is 73. And I see some really crazy suggestions of maybe other ways to express the number 73. Let's keep going. Yeah, and thanks very much for people in the comments for, like, asking these mathematical questions and responding to other people's mathematical questions. Our goal with all of this is to have fun, is to have a healthy environment where people can talk about math together. Hopefully you guys are enjoying the chance to chat about math. I'm certainly getting very entertained by reading the things that you guys are writing also. And by the way, it's this kind of thing that got me interested in math. Hanging out with other middle school students when I was in middle school, thinking about crazy problems together, and then trying to explain our creative ways of expressing 9. Next. One stamp is randomly selected from a 10 by 10 sheet of 100 stamps. What is the probability that the stamp selected is not along an outer edge? Express your answer as a common fraction. This is a trick question. The answer is not 9 times 9 over 10 times 10. I got this kind of thing wrong so many times when I was in middle school, okay? Where it's like, oh yeah, so 10 by 10, right? So like just avoid the edge. So avoiding the edge is 9 times 9, right? Oops, there's like edges on all sides, like the top and the bottom. So in fact, if you look at a page of stamps, or like a, whatever you call this, sheet of stamps. If you look at a sheet of stamps, it's these in the middle. That's the 8 times the 8. Does that make sense? Like these are the ones which don't have anything on the outer edge. So the answer is 8 times 8 divided by 10 times 10. And I remember getting like problems like this wrong on math counts, where it was something to do with like picture frames and boundaries. Okay. That's so funny. The age, okay, so yeah, this shows I'm old. The age I grew up in had picture frames. Now we just look at it on phones. Anyway, so the answer is 8 times 8 divided by 10 times 10. Do people actually use picture frames anymore? I'm quite curious. So okay, let's keep going. What is this? Oh, cancel some stuff, right? This is 4 and this is 5. And over there it's also 4 and 5. Now I'd like to multiply that. So we got, people said that they do use picture frames. Okay, good. So I'm not that old. 16 over 25, and that looks to me like the answer. 16 over 25. Yay, 16 over 25. Okay, more questions. The WNBA champions have a 12-player roster that includes 2 superstars. If a group of 5 starting players for this team must include the 2 superstars, how many different groups of 5 starting players are there? Aha. So this is one of these combination questions, right? So first of all, the 2 superstars, they're in. And that's supposed to be 5 starting players. So how many players do I have left? 3. I have to choose 3 players, right? So, and by the way, there were 12 players to begin with. I need to choose 3 players from how many players to begin with? 12, right? Well, 2 of them are the superstars. So from 10 non-superstars. Okay, so now this is one of these like choose questions. In fact, this is combinatorics. I'm just going to talk through how I do the multiplication, which is how I always remember why it's true. And if you want to know how to do this, well, this is the number of ways is equal to, there's 10 ways to choose the first player from the 10, right? Got 10 non-superstars. And once that person's been picked, how many people do I have left to choose from? They're gone, so there's 9 left. 9 left after that one's gone. Okay, chosen away. How many choices do I have left for the next one? 8 left. Oh, so is the answer 10 times 9 times 8? No, because there's this order that matters. You see, because if I went and chose the first person, I don't know, what are their names? Like Alice, Betty, and Claire. If I chose Alice first and then Betty and then Claire, that's actually the same setup as choosing Claire first and then Betty and then Alice. So I need to divide by the number of ways I could have rearranged these three people as I'm calling them out. And the number of ways I can rearrange three people is 3 ways to decide who's first, 2 ways to decide who's second, and 1 way to decide who's last. And this is actually often written as 10 choose 3. So maybe I should say this is actually written as 10 choose 3, often like this. Sometimes people write it as 10 choose 3. And sometimes you put the 10 and the 3 in different places with the C. All of them are legitimate. But if I want to work this out, somehow you just cancel away. 3, 9, 3. 2, 8, 4. Oh, that's the answer I see in the chat. 120. So the answer is 120. If you like this kind of math, by the way, I actually have some good news for you. I don't know if any of you want to do more math, but I'm actually teaching a class for my college students at Carnegie Mellon University starting on Monday. It's a class on combinatorics. And because these days universities are all doing everything, well, not all the classes are remote, but mine is. So I'll actually be broadcasting from this studio every other day, Monday, Wednesday, and Friday. The entire class from Carnegie Mellon University. It's free. If anyone wants to watch it, you'll be learning combinatorics with college students. But anyway, that's actually one of my favorite subjects, combinatorics. So this is 120. What do we have here? Yeah, 120. Oh, people want to know when it is. Unfortunately, I think many of you might be at school. I need to know when it is. I forgot when it is. It's on my website. I'll find out. I sort of live day by day. It's somewhere in the afternoon. I think it's like 2:10 to 3. But that doesn't sound right. Maybe it's... Oh, I think it is 2:10 to 3. Anyway, I think it's 2:10 to 3. I'll figure out what day my class is by the time my class starts. I think it is 2:10 to 3 Eastern Time. Someone here is probably going to tell me what it actually is. Yeah, I am the teacher. That is right. So the bottom line is I need to know when my class is by Monday. Aha, somebody else has helped. It's some person. Thank you, some person. Let's keep doing problems. 2 pencils and 1 pen cost 80 cents. And 1 pencil and 2 pens cost $1.15. How many cents would 3 pencils cost? Oh, this question is awesome. Okay. So I'm going to do it in a way which doesn't use algebra. Okay, this question is awesome. I'm going to draw a chart. And we're going to see an interesting pattern, okay? What is this? So I got some pencils. And I got some pens. Okay? Oh, I need one more column. It's the cost. Of course, the cost. Okay. Now, I want to know how much 3 pencils and 0 pens costs. So I don't know what that is yet. Okay? The next thing is, I do know what 2 pencils and 1 pen costs. Oops. 2 pencils and 1 pen costs 80 cents. Oh, everything's in cents, okay? Notice I paid attention right away to the units because it said how many cents. Great, let's just write down cents. No more dollar signs, no more periods. And just to remind people, that's in cents, okay? And then the next thing is, if I had 1 pencil and 2 pens, that's 115 cents. Now, does anyone see an interesting thing about the pattern of what I've written here? Notice I said I'm not even going to use algebra. 3, 0, 2, 1, 1, 2. What's the deal? Why did I write them? Actually, also, why did I write them in this weird order? I went and wrote the 3, 0 next to the 2, 1, next to the 1, 2. It's like there's a pattern, right? When you go up a row, what happens? You're exchanging. So let's just look at it this way. If I'm doing this, what am I actually doing? I'm being like, I want more pencils. More pencils. So I'm just turning pen into pencil. That's what's going on here. This is what happens when you transform a pen into a pencil. Oh my gosh, I'm going to have some fun. This is what happens when you plus a sill. Okay? Because that's how you change a pen into a pencil. As you know, you add a sill. Okay, so adding a sill reduces by whatever that is, okay? So in that case, like, I just need to do it again, right? Let's add another sill. So now all I have to do is figure out what happens. I see people are doing the math already. To go from this guy to that guy, I just have to subtract 35. 115 minus 80 is 35. So clearly, adding a sill is cheaper. Pencils are cheaper. Okay? So in that case, this thing is like minus 35. Therefore, I just need to do it again. Minus 35. What's 80 minus 35? Again, always be careful of the borrowing. All right? I spent too many times in my life saying, the answer is 55. But nope, you got to be careful because you got to worry about the borrowing. So it's not 55, it's 45. Okay? So my proposal is that the answer is going to just be 45 cents. But I want to tell you something else too. So this is something I learned when I was doing my PhD. I saw somebody ask, did you have a PhD? The answer is yes. And what I learned in one of the things I learned in my PhD is a neat fact about what happens with these things called arithmetic progressions. Actually, you don't need a PhD to learn this. It's just that the kind of math I was doing, this kind of came up, and I just had never thought of it this way before. But it turns out that if you ever have three things which are equally spaced, the middle one, if you multiply the middle one by 2, it's the sum of the other two. It's just a neat fact. Like, if you multiply the middle term by 2, that's going to be the same as adding those two together, because you see what my fingers did? It's like they just moved apart by the same amount. You can actually use that trick to get to 45 also. That's how I would double check this problem. Right? So if I have this like not really consecutive numbers, but like equally spaced. Yes, that's right. Penguins. Thanks, penguins. The middle one's the average of the other two. This is a really nifty trick for doing questions fast. Okay? So if the middle one's supposed to be the average of two of them, that means if you double the middle one, then that's the sum of these two. Is it easy to double 80? Yeah, that's 160. So the other way I was actually checking the 45 in my head is I was like, actually the answer is also double of the 80 minus the 115. Did that make sense to people? Because like it should be, double of that and then minus the one I've gotten already. So it should be 160 minus 115. And if I actually wanted to do that, if you subtract, you borrow 45. And so that double checks your answer to be 45. This is like an example of how when I was doing math counts, the way you go and make sure you don't make mistakes is you get like two really different ways to solve the same problem. Like, look, this one we went and figured out 35 and we subtracted 35. And this one we just said double the 80 and then subtract the 115. The chance that you make the same error twice is quite low. Wait, no, the chance that you make the same error twice is quite high. But the chance that you make with two different methods get the same wrong answer, now that's low. So that's just why it's nice to know these other ways to check a problem. 45. Is that the answer? Yes, it is. Okay. Oh boy. We're kind of slow on this, but that's because I've been having fun explaining everything. Let's keep going. All right. Number 12. There are 8 furlongs in a mile. There are 2 weeks in a fortnight. The British cavalry traveled 2,800 furlongs in a fortnight. How many miles per day did the cavalry average? Okay. So what do I need to do here? I mean, sometimes it depends on how you like to think about these things. I see so many different units. If I want to convert these, the way I often think of it is I actually like to think of what I'm doing, like one step at a time. 2,800 furlongs in a fortnight. Okay. And if I want to know how many miles in a fortnight, let's do one at a time. If I want to turn them into miles, well, then I need to say there are 8 furlongs per mile. So I would have to take 2,800 divided by 8 to get the number of miles in a fortnight. I know some people like to do this by multiplying these like ratios, where you write things like 8 furlongs divided by 1 mile. There's nothing wrong with that at all. This is just how my brain works. I like to just like see one thing at a time. And my sanity check is like, when you go from furlongs to miles, your number needs to get smaller because there's 8 of them. There's 8 furlongs in a mile. Next, if I go to per day, well, what happens here? So if I want to know, if that's how many I was going in a fortnight, if I want to know miles per day, a fortnight's longer, okay? So actually, a fortnight is 14 days, 2 weeks, miles per day. And I'm just double checking, would it make sense that I'm dividing both times? Yes, because furlongs are smaller things than miles, and fortnights are bigger things than days. Okay? So now if I do this, let's go and figure out what the answer is. Let's go and cancel. 14 into 28 is actually 2. So that's 200 divided by 8. Thank goodness. I wanted to make sure the answer was a whole number, because the question didn't say as a fraction. And 200 divided by 8, that's nice, because 100 divided by 4 is 25. And you can actually cancel that out. Like, let me just quickly do the cancel. If I divide out a 2, it's 100 divided by 4, which is 25. And that's miles per day. Sanity check. Does that make sense? Can you go 25 miles per day? Actually, you can. I know this because at some point when I was in college, I went hiking Yosemite. There's this half dome that you can hike. That was a 17-mile hike in a day. And I survived. We did that in a day. We walked 17 miles in a day. So if you can walk 17 miles in a day, I could believe that the cavalry could move 25 miles in a day. I would actually expect them to maybe go a little bit faster. But let's see if the answer is right. 25. Okay. A marathon is 26.2 miles. You're right. So if you can run a marathon, you'd also say that's not a very big deal. These cavalry are not that fast. Okay, let's keep going. Two cubes have edge lengths of 6 inches and 12 inches. What is the ratio of the surface area of the smaller cube to the surface area of the larger cube? Express your answer as a common fraction. You don't even need to figure out the surface areas of each of them, because it turns out that from the 6 inches to the 12 inches, what did you do? You multiplied by 2, right? So what happened is that you blew it up by times 2. All right, that's all that's happening. Now what you want to know is what happens to the surface area when you blow up by 2. Is it that you multiply by 2 cubed, or by 2 squared, or by 2, or like 2 to the power of 50? Well, it's multiplying by 2 squared, because if you think about it, it's like every little square on the cube blew up into twice in each direction, right? So the amount that the area multiplied by is times 2 and then times 2 again. So if I was looking at just like one side of the cube, one face of the cube, that's going to blow up into twice and twice, right? So it's like times 2 and then times another 2. So the area, surface area, blows up by times 4. All areas multiply by 2 squared, which is times 4. And the question says what's the ratio from the smaller to the larger. So the answer is not 4. The answer is 1/4. Let's see if this is right, okay? And by the way, if you worked out the actual formulas for surface area, you would get this too. But the beautiful thing is, even if you did this with like weird shaped objects, like some of those 20-sided dice, if you had a 20-sided die with some size and you go and blow it up by a factor of 2, the surface area is going to change by a factor of 1 to 4. The ratio would be 1/4, okay? And we're good. Let's keep going. Oh, I love these names. Math Counts, you have the funniest names. I think Philanthropist was around when I was doing Math Counts too. So this person just like lived forever. Philanthropist won a great deal of money in a contest. He gave 20% of his winnings to his parents, 25% of the remaining money to his children, and the remaining $900,000 to his favorite charity. What was the total number of dollars that Phil won? Okay. I often think of this as like some sort of a pie. There's something here which actually, I think I did this question before when I was growing up. I vaguely remember doing this exact question before. So I'm very curious, actually, Math Counts organizers, if this is actually an old question, because I remember that name Philanthropist, and also I think these were similar numbers. But anyway, I like it. So Philanthropist, you're here. And that's clearly your amount of money. And 20% of the winnings went to the parents. How do you draw 20%? I don't know. Maybe like a little bit less than 25%. So 20%, by the way, is 1/5. So 1/5 went to the parents. Okay? Next, I have 25% of the remaining. Oh, that's so convenient. The remaining is 4/5, right? So if I want to give a quarter of the 4/5, I give away another 1/5. You see how I'm thinking about this? There was 1/5 here. There's 4/5 left over, and a quarter of the rest. That's 1/5. Well, a quarter of 4/5 is 1/5, and that means that all this stuff is 900,000. Here's a tip: if you have giant numbers, K stands for kilo, and you can use that to represent 1,000. So that's 900K. And what was the total amount of dollars? Okay, so if that's 3/5, and I want to know what's the total, now I know what 1/5 is. 1/5 is a third of that, right? So 1/5 is 300K. And so if I want to finish it, the whole is 3 times 5, 1,500K. I saw people say like 1.5 mil. That's how we'd often think of it. But in this problem, we can't write a K. We have to actually write the number. 1,500,000. So this probably is how much philanthropists just won in the contest. There are other ways to do this problem too. You could actually go and take these things and you could go and multiply fractions together. And I encourage you to play with other methods too. But the numbers were just so nice, I just, ran it this way. Is that the answer? People are asking, why couldn't you keep all of it? Well, actually, what really happened after philanthropists won the great deal of money is that philanthropists had to pay tax on it. But that's not on this question. So if you're worried about all these amounts, actually, if you go win this amount of money in a contest, you got to pay tax, and that's going to take some chunk off. Okay. And we have 1.5 million. Okay, let's keep going. Oh man, we're running out of time. Okay, 2 circles with spinners at their centers are divided into 3 equal regions as shown. When both spinners are spun, what is the probability that the product of the 2 values is negative? Express your answer as a common fraction. So if I want to get a negative number, how do you do that? Well, you either have like a negative times a positive or a positive times a negative. But those are the only 2 cases. Let me see if the picture is on the next slide. It's not, so I'll do it here. So I need to know the different ways I could get this. I could either have a positive and then a negative. And as you can see, I'm thinking about like where to fit this given my head is in the way. Let's just try to fit it here, okay? I can either get a positive and a negative, or I can get a negative and then a positive. If I want to get a positive and then a negative, what's the chance here? Well, I have to take 1/3 chance on this positive, because that's 1/5. And if I want to get a negative over here, it looks like there's only 1 over there, so it's 1/3 chance. And if I want to get a negative and then a positive, actually it's just the complements of both of these fractions. Actually, not the reciprocal, but the complement, like subtracting it from 1. Because if positivity chance is 1/3, negativity chance is 2/3. And here is 2/3. Because there's 2 things which are positive. You can see what's going through my mind. I actually paused because I looked at it and I was like, is it really 2? Yeah, it's 2. So I'm double checking with all these different ways. One way was subtract it from 1, okay? Then 1/3 becomes 2/3. The other way was, is it really 2? Yeah, it's really 2. And now if I have this stuff, I just need to add this together. Oh, look, common denominator is already there. So it's 1 times 1 over 3 times 3, which is 1/9. And over here, 2 times 2 is 4, over 3 times 3 is 4/9. I just need to add them, okay? Oh, somebody here wishes they were a math nerd. It's fun. Welcome to the math nerd crowd. We get to go and think about all these different ways of solving questions. And that's actually entertaining. 1/4 plus 1/9 plus 4/9 is 5/9. And I'm going to propose that as my question. I'm going to propose that as my answer. Yeah, this is not Jeopardy. I have to say the answer, not a question. Next question. Sprint round number 16. Oh man, how do you read this? Let's see. Cheldelin Middle School. Cheldelin Middle School has 12 doors to enter or leave the building. In how many ways is it possible to enter the building by one door and leave the building by a different door? Wow. Okay. Well, it looks okay to me. It's like there's 12 doors to enter or leave. I can use each door to enter and to leave, right? So I've got enter 12 ways and leave 11 ways because it's a different door. So I guess the question just amounts to, how do you multiply 12 by 11? There's a beautiful trick. See how you multiply 12 by 11? You write 12 and you put 1 plus 2 is 3. You add them up and put them in the middle. That's 132. This trick actually generally works. It doesn't work if you have to have a number and you add up and it's more than 9, if it's 10 or more, but then you just carry to the next one. I don't have time to talk more about that here, but there are lots of these nifty tricks with arithmetic also. I think the answer is 132. Let's find out. It is. Okay. Next question. Sue is 4 times as old as Tom is now, and she is 8/3 as old as Tom will be in 7 years. How many years old was Tom 3 years ago? Okay, this thing, unfortunately to me, has too many like befores and afters and fractions for me to do it without variables. So I'm going to use variables because I think that seems quite reasonable. But a tip I give to everyone, if you're going to use variables, make sure you say what they mean because there's too much like now and ago and all of this. All right? So let's go and make the variables for now. S is equal to how old Sue age now. And we have a T. Tom age now. You see, I actually wrote those down. That's how I don't get confused later. All right? Notice I also tried really hard to make this not look like a 5. I've made so many mistakes before where I wrote an S, I thought it was a 5, and I got it wrong. Now let's go and write some equations. What do I know? I know that Sue is 4 times as old as Tom is now. So I know one equation is Sue's age is 4 times Tom's age. Now let's translate the next thing. Sue now, so she now is 8/3 as old as Tom will be in 7 years. Okay? So now I have this information. I need to go and figure out how many years old was Tom 3 years ago. I like this. The reason I like this is because I need to know T, basically. Can I get rid of S somehow? I can, by substitution, because they're both equal to S. So in that case, I just set these equal to each other, because 4T is S, which is this. So now I have that 4T is equal to 8/3 T plus 7. I think the cleanest way to deal with this is to multiply out that 3. So then I get multiply both sides by 3. 12T is equal to 8T plus 7. Now open the bracket. 12T is equal to 8T plus 8 times 7 is 56. Hey, we saw that earlier today. So then that means that 4T is equal to 56. I just need to divide 56 by 4. When I said we saw that earlier today, we know that 56 is 8 times 7. If it's 8 times 7, what happens when you divide by 4? Then it's 2 times 7, right? 8 times 7, take 4 out of the 8, divide the 8 by 4, you get 2. So this is just 2 times 7, which is 14. And the more problems that you do in this way, the more often you'll see like, oh, 56 divided by 4 is 14. So the answer is 14, right? Don't get too excited. Always be careful. Read the question. It says, how many years old was Tom 3 years ago? So if it's 3 years ago, I can't say the answer is 14. Age now is 14. And so 3 years ago, Tom was 14 minus 3, which is equal to 11. Okay, let's see if this is right. 11? Yes, it's 11. Okay. Wow, that was really quick. That was our first hour. I've learned a little bit about pacing myself during these live streams. I think what it means is we'll go marginally faster next time. The number of questions we have to do over this 3-day session is that there are 30 sprint round questions and there are 8 target round questions. And if you do the math, we got like more than halfway through the sprint round, but they get harder as you go along. So I think that our pacing is probably just about right to finish everything in these 3 1-hour sessions if I go up a little bit of speed next time. Hope that you guys had some fun today. I certainly did. If you can tell, I actually really enjoy doing these math counts problems. It brings back good memories, but also they're actually pretty neat. If you saw some of these, I got pretty excited about. I think that they make good questions. I hope you guys thought this was interesting because, you don't need me to do these problems. You can do them too. And if you just yourself use your free time, doesn't matter whether you're on a math counts team, doesn't matter whether you're too young, doesn't matter whether the season's over. These are fantastic kinds of things to think about. And I'm really glad that we had this opportunity to think about them together. All right. Well, it was a real pleasure talking to you all today. We'll be back again tomorrow. It'll be the same time, 5 o'clock p.m. Eastern Time. We'll do an hour, and we'll continue from question 18. See you then.